The quadratic formula. Okay, solve a quadratic equation. Now, it has to be quadratic. So the general form or the standard form of a quadratic equation would. So I'm not sure why part of this. Okay, so the general form of a quadratic equation. Um, okay, so remember the general form looks like this. It's ax squared plus bx plus c equals 0. So if you're going to use quadratic formula, 0 has to be on the other side. If you complete the square, if you solve it completing the square, you got to bring that constant to the other side. But if you're going to solve using quadratic formula or factoring, remember when we did the factoring earlier? You have to have 0 on the other side, so it has to be in standard form or general form. And you got to remember that the coefficient of x squared is a, the coefficient of x is b, and your constant is c. But it's got to be in this form first. And so once it's in this form, then the formula is this. X equal, I'm using x because that's my variable, so it's whatever your variable is. So x equals the opposite of b. That's what this says, the opposite of b. So whatever b is, you take the opposite of it. Plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then it turns out that radicand, and what's your radicand here? What's that expression? The radicand, remember the radicand is the expression under the square root. So that's b squared minus 4ac, right? That's called the discriminant. Right, the discriminant. D-I-S-C-R-I-M-I-N-A-T-E. So we're going to talk about that in a little while. All right, for right now, you don't need it, though. For what we're about to do, you don't need to know that this is called the discriminant. Okay, so let's look at this example. Let's solve this. Okay, x squared plus 5x plus 2 equal 0. X squared plus 5x plus 2 equal 0. All right, so is it in standard form? Yes. So then before you start plugging in numbers, you need to determine what A, B, and C are. So you need to find out what A is, B is, and C is. So A, remember, is the coefficient of x squared. What's the coefficient of x squared here? 1. That's a 1, so A is 1. B is the coefficient of x. What's the coefficient of x? Positive 5. And C is your constant. What's my constant? 2. So there's your A, B, C. So if any of these are incorrect, you're solving a different quadratic equation than the one you need to. So you got to, first of all, make sure you have all these correct. If any of these are incorrect, then obviously your answer is going to be incorrect. So then you just plug it back in. So here's what the quadratic formula says. X equal, this says I take the opposite of B. Well, B is 5. What's the opposite of 5? Negative 5. Plus or minus the square root of. Now with the rest of these, with the radicand, I would go ahead and enclose the A, B, and C in parentheses. So in other words, this says B squared. So what's B? I'm going to put that in parentheses, and what do I do to it? Square it. Now keep in mind that whenever I square a number, it should always be what kind of number? Let me rephrase it. If I square a positive number or a negative number, it's going to be what kind of number? Positive. If I square 0, it's going to be what number? 0. Okay. But it's never going to be negative, right? All right. So this was a negative 5. Don't say that's a negative 25. It's supposed to be what kind of 25? Positive. All right. Minus 4 times A. Put A in parentheses. What's A?
1.
Times C, and what's C?
2.
All over 2 times A, and what's A?
1.
So notice I put A, B, and C in parentheses here. All right, the next step is to simplify your radicand. So I have this. I have negative 5 plus or minus the square root of, what's 5 squared? What's a negative times a positive times a positive? A negative, right? A negative times a positive is a what? A negative times a positive is a what? Okay. So it'll be 25 minus, and what's 4 times 1 times 2? 8. All over what? 2 times 1 is 2. Equal. Negative 5 plus or minus the square root of. What's 25 minus 8? 17. All over 2. All right, so now this is where we're at. Now ask yourself, first of all, is 17 a perfect square?
No.
Is there a perfect square other than one that goes into 17? That's your answer. You're done. Now in my math lab, they're going to ask you to write this as two separate solutions. So you'd say negative 5 plus the square root of 17 over 2, comma, negative 5 minus the square root of 17 over 2. Okay? All right, number 2. All right, let's suppose we had 5x squared plus x minus 2 equals 0. Is it in standard form? So tell me A, B, and C. What's A? 5. What's B? 1. What's C? Negative 2. Not a 2, a negative 2. And then I just plug it back into the formula. So I get x equal. The formula says the opposite of B. What is B here? What's the opposite of that? Plus or minus the square root of, and that's when I'm going to start using parentheses. I'm going to take B, which is 1. I'm going to do what to it? Square it. Minus 4 times A, what's A? Times C, which is all over 2 times A, what's A? 5. So all you do is just plug these numbers back in. Simplifying the radicand, I'm going to get negative 1 plus or minus the square root of, what's 1 squared? What's a negative times a positive times a negative? A positive. 4 times 5 times 2 is 40. So some of you still have issues with knowing that a negative times a positive is a negative times a negative is a positive. Over what? 10. So that's negative 1 plus or minus the square root of 41 over what? 10. Okay, now let's see if we can simplify the square root of 41. Can I simplify the square root of 41? Can I simplify the square root of 41? No. So there's your answer. So you'd say x equal negative 1 plus the square root of 41 over 10, comma, negative 1 minus the square root of 41 over 10. Okay? All right, number 3. All right, suppose we had this. We had 3x squared equal 6x minus 1. Again, solve using quadratic formula. What? What do you do? Put in what form? Use the terminology. What form? Standard form or general form. So when I bring everything to one side, let's bring it to the left. I'm going to get 3x squared. What else? Equal 0. Okay. All right. So then what's A? What's B? Negative 6. Not 6, but a negative 6. And what's C? 1. And you just plug your values back into this formula. So I'm going to get x equal. This says I take the opposite of B. Well, if B is a negative 6, what's the opposite of negative 6? Positive 6. Plus or minus the square root of B, and what's B? Negative 6. Put that in parentheses, and what do I do to that? Square it. Minus 4 times A, what's A? Times C, all over 2 times a, and a is 3. Okay, so now I'm going to go ahead and simplify the radicand. So I get 6 plus or minus the square root of, what's negative 6 times itself? Positive 36. Should never be negative. Okay, what's a negative times a positive times a positive? A negative. What's 4 times 3 times 1? All over what? 6. Equal 6 plus or minus the square root of, what's 36 minus 12? 24. All over 6. All right, so that's where I'm at. Now, you got to ask yourself, first of all, is 24 a perfect square? No. Is a perfect square other than 1 that goes into 24? Yes. 4. So I'm going to go off to the side and figure out what the square root of 24 is. So the square root of 24, no, don't use 8 and 3. You want to use a perfect square. So you want to use 4. 4 times 6. You want to make sure one of these factors is a perfect square. And then you can rewrite this as square root of 4, and you can skip this step. But that's what's really happening. You're writing the square root of a product as the product of 2 square roots. And what's the square root of 4? So you get 2 square root of 6. And so that goes here. So remember, in the previous 2, we stopped here, right? That's why we stopped in the previous 2, because the radical I could not simplify, but now I can. So you want to go further. On my math lab, if you leave it like this, it's going to mark it wrong. So you're going to say 6 plus or minus 2 square root of 6 all over 6. Okay? Now, I want you to notice this. See these numbers right here? 6, 2, and 6. What do they have in common? Yeah. So on my math lab, if you write like this and you don't accept it, then probably want you to reduce it. So what I would do is if I notice that all of these numbers right here, the 6, this 2, and the 6 are divisible by the same factor, I would just write as 2 fractions. I would write it as 6 over 6 plus or minus what? 2 square root of 6 over 6, and then reduce. What's 6 over 6? Plus or minus, and then that's a 1 and that's a what? So what does this become? Square root of 6 over 3. Okay, so 1 plus or minus square root of 6 over 3. Now, another way, see right here, if you remember from last semester, you could have done this as well. So there are multiple ways of writing the answer. On my math lab, though, they probably did want you to reduce. So you see where the 6, the 2, and the 6 are all divisible by what number? 2. So I'm going to go ahead and rewrite this to show what I'm doing. So in your mind, you're going to say 6 divided by 2 is what? 3. 2 divided by 2 is what? 6 divided by 2 is what? And your answer would be 3 plus or minus square root of 6 all over what? 3. So that's another way. So these are all the same thing. This is the same thing as this is the same thing as this. They're all the same. It kind of makes sense because what's 3 over 3? 1. And you get a square root of 6 over what? 3. It's all the same thing. Okay? All right, so any question on quadratic form? And that's all that is. All right, so it's very simple. The quadratic form is just plugging numbers back in. And you all had it. Now, you should remember that more than you should remember the completing the square. You should remember the quadratic formula more than you should remember the completing the square previously.
We should take a break now.
Yeah, last time you took a break, some of you stayed 10 minutes. You're supposed to only stay what? 5 minutes. Okay, so hold on. So what we're going to do in a little while is we're going to talk about the discriminant. It's very simple. This is discriminant, b squared minus 4ac. So let's just go ahead and take 5 minutes. At 5 minutes, it's now 7:38. From your watch, you say 5 minutes.